lesson 4.3 is modeling with quadratic functions. So, review, we keep seeing this review. Quadratic function, first of all, we remember that standard form is that f of x equals ax squared plus bx plus c, and the graph of a quadratic is a parabola. Okay, old news there, right? We again review. The above function can also be written in the form f of x equals a times x minus h squared plus k. And this is our, keeps not being in here, vertex form. Now, it says right there, guys, this section involves solving a system of equations like we did in chapter 3. So we're going back and reviewing that substitution elimination. Difference here, you're not given the equations to start. Okay? And we have a, what's the word? A system of how to write the system of equations. Okay, so it's not like you're reading a word problem and trying to write the equations. We have a process we're going to use. There's a good word, process. So, let's look at this first example. A parabola contains points 0, 0, negative 1, negative 2, and 1, 6. Okay, so you can graph those if you want to. Not necessary, though. The question is, what is the equation of the parabola in standard form? So when I say that I am looking for standard form for my final answer, what is standard form again? Okay, now one difference is I'm going to write y equals. Same idea though. So y equals ax squared plus bx plus c. That is my goal of what I want to write in the end. Which means I need to find three things. I need to find A, B, and C. Okay? So, notice we aren't given three equations, but we're given three ordered pairs, points. So that's what we're going to use here. And let's see. Obviously, you guys realize there's lots of room for a reason. So, the first point we're given is 0, 0. And remind me, what do I know about an ordered pair? An ordered pair is? What are the numbers in an ordered pair representing? X and Y. There we go. Okay, so what we can do here, this 0, 0 represents 0 for X and 0 for Y. Now, 0, 0 actually makes it pretty easy. Every place in this, using this standard form, y equals ax squared plus bx plus c. Every place I see an x, I'm going to put in a 0. Every place I see a y, I'm going to put in a 0. And we're going to have a resulting equation. So in this case, y is 0 equals a times x squared, which is 0 squared, plus b times x, which is 0, plus c. As I said, this one, I love the point 0, 0 because it makes it nice. What's that clean up to be?
B plus C. A plus B plus C.
Okay, so A times 0 is 0. B times 0 is 0.
Let's see, 0 equals C.
So we are left with 0 equals C. Officially, okay guys, they don't all happen like this, but officially that means that is one of my equations. You know how we're supposed to have equations 1, 2, and 3 here? That's one of them. And that's the easiest one, but that's also going to make this problem a lot easier than it otherwise could be. Okay. Now, that gives me equation 1. To get equation 2, repeat the process using the next ordered pair. So what's my next ordered pair? Negative 1, negative 2. And the ordered pair, negative 1, negative 2, represents x, y. I'm even going to write it here, guys. X, y. So, every place I see an X, I'm putting in negative 1. Every place I see a Y, I'm putting in negative 2. So, using this standard form. So, Y equals means I'm saying negative 2 equals A times X squared. What am I putting in for X this time?
Negative 2.
Negative 1. So A times negative 1 squared plus B times X, and B is, or X is, negative 1,
1.
plus C. Clean that up. I still have negative 2 equals. Negative 1 squared is 1 times A is
A.
1A or A. B times negative 1
B, negative B.
minus B, and then plus C. That is what I'm going to call equation 2. And I'll number them over here when I get to the next part.
I think I wrote too big.
I know, I kind of wrote too big almost. So someplace figure out, and okay guys, because one of my equations is C equals 0, we're going to have room to spare here. Okay, I mean, you can make this work. So find a spot, maybe just kind of over to the right here or something, or up above, whatever, to write your equation 3. So how am I going to find equation 3? Now I'm using the ordered pair, 1, 6. And same questions I keep asking. What do 1 and 6 represent? X and Y. I keep going back up to that standard form. Since it's Y equals, I'm going to do 6 equals A times X squared. So A times 1 squared. Plus BX. So plus B times 1 plus C. Clean it up. 6 equals 1 squared times 1 is 1A.
1.
So A. B times 1 is plus B plus C. Okay guys, what did I just create?
You created the 3 equations.
Equations 1, 2, and 3. So I'm going to come over to the side here and list my 3 equations together somewhere. So equation 1 is C equals 0. And I'm flipping these around as I write them, just because that's more natural. Equation 2 is A minus B plus C equals negative 2. Equation 3, A plus B plus C equals 6. Again, kind of like last chapter, number them, don't number, that's your choice. How do you keep yourself organized?
And then we basically just do what we did in the last chapter.
Yes. Well, okay, again, we don't have 3 typical equations here, do we? So the work is kind of shortened.
Because we already have C.
We already know one of our 3 answers, yes?
We can fill out B and find the A. Well, the B's are already like the one or 2 or 3. You can cancel the B's.
Okay, so here's what it comes down to. Of course, is there just one correct direction to go from here?
Yes.
Okay. I would disagree, there's not. Okay. Keaton just made the comment of you could add these 2 equations together and B would cancel out, yes? Now, if B cancels out, then you have an equation that has A and C in it.
Yeah, but
However,
we already have C.
we already have C, so then you could plug C in and you'll have A.
Okay.
And then you plug it back in and you have B. Now, I'll be honest, this is not the direction I was going to go. Okay? Am I, is Keaton more right or less right than me? Neither. It's just different. Here's what I was going to say. And honestly, I might like Keaton's better. I don't know. I was going to say, take C equals 0 and plug it in to both of these equations. And really, it's a different direction, same idea. I was going to say, take C equals 0, plug it in both these equations, and then add the two, you'll have two AB equations that you can add together, and you'll eliminate a B there. Really, Keaton and I are doing the same thing. We're just reversing our steps.
Yeah.
He's adding and then plugging the C in. I was going to plug the C in and then add. Okay.
This is more better.
It always comes down to, I know, I was laughing at the grammar, but it comes down to what you see, guys. You know, I've told you all along. I'll give you the idea of how to do these, but the advantage is here, you guys know where we're headed.
Yes.
I'm going to go,
It's more better.
I like Mrs. Stark.
I like Mrs. Corbin's too.
honestly, I like them both, I'll be honest. Okay.
Let's go Keaton. Let's go Keaton. What?
Now, here's what I'm going to say. I'm going to stick with my way. However, if you see where Keaton's way is going, try it. Go for it.
It's going pretty.
I think they're both very doable. So what I'm going to do is I'm going to take my C and I'm going to plug it in to both equations 2 and 3. So on equation 2, when I plug in C equals 0, my new equation becomes A minus B plus 0. Do I need to write plus 0? No. So it's just going to equal negative 2. I'm going to rewrite equation 3. It's A plus B plus 0. I don't need to write plus 0 equals 6. Now, if you feel the desire, you can call these equations 4 and 5. I'm not sure it's necessary in this situation. Okay, but that's technically what we kind of just did, is we just really created equations 4 and 5. What do we do with these two equations?
You plug them back into.
No, you cancel the B's.
Okay, my direction, you're going to cancel either the A's or B's. I'm eliminating here. Okay, I'm eliminating. So I'm set up, since my B's are both 1B's but opposite signs, I'm set up to eliminate my B's. What's A plus A?
2A.
2A. Negative B plus B cancels. What's negative 2 plus 6? 4. If 2A equals 4, divide by 2, and A equals 2.
Same, I did your way. Bam.
Okay, I could have been done a lot quicker going my way if I, when I'm not explaining. Okay, guys, am I done?
No.
I got C, I got A. Can you find a way to get your B?
Way back in the
Plug it back into either equation 2 or 3.
Or you can use 4 or 5.
Okay.
I agree. Really, you can use any legitimate equation that involves a B. My brain was saying 2 or 3 at first as well, but then valid point, 4 or 5 work as well too.
More better.
It's more fun.
It's the more butterest of all.
Okay,
More butterest.
pick something and find your B.
More butterest.
How about if I'm going to use 5. A plus B equals 6. So then, 2 plus B equals 6. Subtract my 2. B is 4. Here's what it comes down to. Have you guys found the same ABCs as me? Okay. Now, last chapter, we were solving a system of 3 equations. We wrote a ordered triple. What did this problem ask me to do? Standard form.
Standard form.
Standard form is ax squared plus bx plus c. Do we know ABCs?
Yes.
Yeah. So it's just a difference of how we express. Okay? It's y equals ax squared plus bx plus c. So y equals 2x squared plus 4x plus 0. No. My rule of thumb is, do you have to put the plus 0? No. Can you put the plus 0? You can. I won't count it wrong. Math Excel will not make you put the 0. I can guarantee that. They would prefer if you don't. Will they count you wrong if they put the 0?
Probably.
I think so. Yeah, because I put the 0 last night and it counted as wrong.
And they didn't like the 0. Okay, so
Math Excel's
I mean, me grading paper and pencil, I won't count you wrong if I put the 0. It's equivalent. Okay? Better form is to drop off the 0, though.
Are we doing B?
I was actually,
I feel like we should do A and then Monday
I think I might reverse that.
I feel like we should do A for day and B for B is Monday.
I think we should do A.
I think we should be done.
Okay. I think actually,
Let's do it.
And these tomorrow.
okay, listen,
I'd rather meet Monday.
I said I'd give you more work time, yeah.
No, I'm in.
I'm going to, okay, it's Friday. I don't want frustration Friday. Let's flip to the back side to do B. The difference, here's the difference. If we did that A on the bottom, it works out to have fractions. So, I'm picking the nicer of the two problems. Now, okay, so, the problem we just did, you guys realize you got the easy version, yes? We got the easy version because we knew our C from the moment we started the problem. This next problem is going to involve 3 full equations. So we're going to go more the full route here. That's the difference between the two problems. So I'm flipping to the back side. We're given ordered pairs. Again, remember, you are being asked to go for standard form. And what is that standard form?
Y equals X squared plus BX plus C.
Just like the problem on the previous page, we are given 3 ordered pairs. It's just that it's an XY chart this time, right? And I'll be honest, we don't have a 0, comma something. That's what makes the problems nice. Okay? So, first ordered pair we are given is -1, 2. And in -1, 2, you know -1 is an X, 2 is a Y. They just got changed. Okay, so Y equals means I'm going to write 2 equals AX squared. So A times -1 squared plus BX. So plus B times -1 plus C. As you get better and more confident at this, you could go ahead and write out that next equation without writing the initial equation, right?
Is that a dot by the?
Multiplication dot right here?
Yeah.
Yep. Now, so I have 2 equals -1 squared times A is 1A. B times -1 minus B plus C. There's an equation.
One down.
Okay. Next ordered pair we're going to use 2, -4. Remember, 2 and -4 are X and Y. Needless to say, you don't have to write those X, Y's on there every time, but that's my helpful. y equals -4 equals a times x squared. So a times 2 squared plus bx, so plus b times 2 plus c.
So really the y value is not might use at all.
The y value is only used on the equal sign by itself. So -4 equals, what do we have here? 4a plus 2b plus c.
To be true.
And ordered pair 4, 2. 4 is my x, 2 is my y. Y equals 2 equals a times x squared, so a times 4 squared, plus bx, so plus b times 4, plus c. 2 equals 16a plus 4b plus c. Okay. Okay. Now, me personally, it's all how you want to do it. I'm going to go put my 1, 2, and 3 next to each other so I can see what's going on and decide where I want to go. So I'm going to flip them around as I go. Equation 1 is A minus B plus C equals 2. Equation 2 is 4A plus 2B plus C equals -4. Equation 3, 16A plus 4B plus C equals 2. Okay, guys.
I think we should consider the B's already negative.
Well, okay, so first of all, keep in mind, we technically had an elimination method and a substitution method for this stuff, didn't we? Now, to me, this one's more set up for elimination. Okay. Next thing, which variable is going to be easiest to eliminate? Which one?
I think the C's, but with the B's already negative.
Okay, but here's what I would say. I would say C's because they're all 1 C's. You're going to have to pick an equation and multiply by a negative. But then you can use that twice. Okay? If we do A or B, I get that there's a negative B there, but then you have to multiply that equation by 2 one time and 4 the other time. Again, is there a right or wrong answer? No. Okay?
Yes.
Well, okay, but is there a right or wrong path? I mean, again, I guess there can be wrong paths, but you know what I'm trying to say. So, I definitely, honestly, on these problems, guys, I'm always going to say eliminate C. Okay? My opinion is always going to be that we want to eliminate our C's. Because you're always going to have plus C on all 3 equations. Now, I would pick one of these, multiply by -1, and use it both times. Honestly, I think I'm going to multiply the top equation by -1. And here's my reasoning. Because my other 2 equations have bigger A and B values. And so it might set me up a little bit better there. So take turn. What I'm going to do is take turns putting 1 with 2 and 1 with 3. I'm also, because I prefer my bigger numbers on top, I'm going to put 2 on top of 1. Does that make sense? I'll write it out and see if you guys can see what I'm doing. So if I'm putting 2 and 1 together, 2 I'm going to leave as is. It's 4a plus 2b plus c equals negative 4. 1, what did I suggest I was going to do to 1? Multiply by negative 1. So it's negative a plus b minus c equals negative 2. I have a plus c and a negative c, so my equations are set up to cancel the c's, add the c's. 4a plus negative a, 3a. 2b plus b, plus 3b. C plus negative c. Negative 4 plus negative 2, negative 6. What am I going to call this? I'm going to call this equation 4. Again, I'm trying to make life easy on myself. Can I take that negative version of 1 now and put it with 3? Okay. So if I'm doing that, that means I'm putting 3 and 1 together. 3 is the 16a plus 4b plus c equals 2. 1, after I multiply it by the negative, negative a plus b minus c equals negative 2. My c's have opposite signs again. Again, I'm set up to add. 16a plus negative a. 15a. 4b plus b. 5b. C plus negative c. Gone. 2 plus negative 2? 0. I'm going to call this equation 5. You see where to go. Now we're going to put 4 and 5 together. For teaching purposes, I'm going to write them on top of each other. I have 3a plus 3b equals negative 6. And I have 15a plus 5b equals 0. Your choice. What do you guys want to do here?
We should do it.
A? Okay. So cancel the a's because we only have to multiply one of the equations by something. I can go with it. They're both pretty easy here. So how do I get 3a and 15a to be the same? Times it by 5. Specifically, we want opposite signs. Make it a negative 5. So my top equation becomes negative 15a minus 15b equals 30. My bottom equation stays 15a plus 5b equals 0. My a's have opposite signs. So they're going to cancel when we add. Negative 15a plus 15a. They cancel. Negative 15b plus 5b. Negative 10b. 30 plus 0. 30. What do I do here? Divide by negative 10. B is negative 3. Okay, this is the type of problem you remember, isn't it? All that work and we have one of our 3 answers. Good news is, though, you've done most of the work at this point. Okay? Okay, so whichever way you guys do it, I hear the argument. You guys are both right. We know B. We need to find A or C now. Go back to either 4 or 5. Does not matter which. 4. They both have their pros and cons. So 3A plus 3B, so 3 times negative 3, equals negative 6. 3A, 3 times negative 3, minus 9. So if it's 3A minus 9, we're going to add 9. So 3A, negative 6 plus 9 is 3. A is 1. Again, as I said, the work at this point is just After Effects. What's next? Okay, equation 1, 2, or 3, something that has a C. So I'll go with 1. Okay, A, which is 1, minus B, so minus negative 3, plus C equals 2. 1 minus negative 3. 1 plus 3, so 4 plus C equals 2. Subtract 4, and C is negative 2. Final question. How do I give my answer? So the answer is not 1, comma, negative 2, comma, or excuse me, 1, comma, negative 3, comma, negative 2, is it? Okay, so I'm going to write that out so I have my formatting. Y equals 1x squared, so x squared, minus 3x minus 2. The idea, guys, if we were to graph that equation, all 3 of those ordered pairs that we were given would lie on that parabola. Okay, what I will tell you, lesson 4.3 is out there. However, it is not due on Monday.
How many questions?
And if it says it's due on Monday, I'll get that changed when I get my lesson plans done for next week. But I don't even think it says it's due on Monday. I think I knew that I was going to take an extra day. Okay?
That's actually not that hard.
And part of the reason it's not that hard because we've been there, done it. You know the process, which is good and bad. You guys know what to expect. Again, good and bad.